Hey PCH, this is going to be a quick video that is very much final aligned that talks about some questions referring to modeling with trig functions from Unit 5. And so let's go ahead and get started with number 1. And again, this is actually going to help you on the R.3 homework with those two review tabs covering the two standards there. So probably helpful to watch this video first or as you work through those problems. Number 1, it says, we have a situation that can be modeled by this function h of t, and then it gives us some more specific information. Ultimately, we're trying to find what the values of a, b, and d are. Before we get into the actual numbers, what I want us to talk about first is just a review of what each of these values stands for in a trig function. When we're thinking about this a value, that represents the amplitude. Which is the distance between the midline of the function and a max, or the midline and a min. What's also included in this a value is whether or not our function has been reflected over the x-axis or over the midline. Because we know our amplitude is always positive, but if this a value is negative, that tells us again that our function has been reflected over its midline. Our b value, that is not directly our period, but it helps us get to our period in the way that this b value is equal to 2 pi divided by our period. And so if we're trying to find our period, we would take 2 pi divided by that b value. Lastly, d, this of course is our vertical shift, which is our midline. Okay, let's get started. The first thing that I always like to do is draw a graph of the information that we have been given. And so I'm going to do that over here to the side. Draw my axes here. My first information is that at t equals 0, when she starts moving, again, she's on a Ferris wheel, she's at a height of 10 meters off the ground, which is as low as she goes. Okay, so 10 meters is going to be our minimum value. After 20 pi seconds, we'll put that here somewhere, she reaches her maximum height of 30. She cannot get higher than that height. That's all the information we've been given. Because this is a min and this is a max, I can go ahead and connect these dots like this, more or less depicting a cosine function for myself. And so let's talk about how we might be able to figure out what our a, b, and d values are. Well, let's go ahead and get started with d first, our midline. I feel like that's probably the easiest thing for us to come up with. Our midline is going to be the average. So d is our midline. It's going to be the average of our max and our min, right? 30 plus 10 divided by 2. That's going to give us a midline of 40 divided by 2 is 20. So our d value is 20. And that makes sense. Next, let's talk about our a value, because our a value, our amplitude, and our midline are very closely correlated to each other. If we have one, we pretty much have the other. Again, our amplitude is the distance between our midline, which is 20, and a min, which is 10. So we'll just do 20 minus 10 equals 10. We can also find our amplitude as the max minus the midline. So 30 minus 20, which of course gives us 10 as well. It's the same value. One thing we cannot overlook here, again, is that this a value also includes whether or not our graph has been reflected. This is a cosine function. When I look at this, I know cosine normally looks something like this. But here it looks like it's been flipped. So my a value is actually going to be negative 10. Amplitude of 10, but my graph has been reflected. So my a value is negative 10. Lastly, we need to come up with our b value, which is going to be 2 pi divided by our period. It looks like if the distance from this min to the next max is 20 pi, then the distance from that max to the next min is also going to be 20 pi. That's going to give us our period, right? Because our period is the distance, in this case, between one minimum and the next consecutive minimum. This is going to be 40 pi. And so in order to find our b value, we're going to take 2 pi divided by our period, which is 40 pi. Our pi's cancel out. This 2 over 40 reduces to 1/20th, and that's our b value, 1/20th. Okay, I kind of took a long time to explain that problem, but I really wanted to make sure that we understood every part of it. And so let's move on to number 2. This one's a little bit easier. Here it's asking us to determine the minimum and the maximum value of the following trig function. Well, we know, just like what we just talked about, our minimum is going to be our midline minus our amplitude. And those two values, our midline and our amplitude, are really easy to pick out from our function. And so our minimum is going to be our midline, like I said, 2 minus our amplitude, which is 4. Our amplitude's always positive. That's going to give me -2. My maximum is going to be my amplitude, or excuse me, my midline plus my amplitude, so plus 4. And that will give me a maximum of 6. And if it helps, I went ahead and wrote in words how we find our minimum and how we find our maximum, right? Midline minus amplitude for minimum, midline plus amplitude for maximum. Okay, let's move on to our last problem. The daily average temperature in Santiago, Chile varies over time in a periodic way that can be modeled by a trigonometric function. The problem goes on to give us some more information. What I want you to do right now is read through this problem and see if you can draw a graph, again, depicting the information that's been given. Right, hopefully your graph looks something like this, right? It tells us that the max temperature on the 7th day of the year is 29 degrees. And then the average temperature of the coolest day of the year is about 14 degrees. That's our minimum. We don't know the x value for that, but that's no problem for us. Now, because this question is multiple choice, we don't necessarily have to do a ton of math. We just need to eliminate answers that don't make sense to us. First, one of the things that I notice is that this function looks like a cosine function, right? We were given a max value and a min value. There's no way we could somehow come up with a sine function to represent this. It just doesn't make sense. And so I'm going to cross out option 2 because that is a sine function. Next, when I'm looking at these answer choices, I notice that number 3 has a midline of 14. Based on what I see in my graph and the knowledge that I brought out of this problem, 14 is a minimum. There's no way that 14 is going to be my midline. And so I'm going to cross out option 3 too, because that makes absolutely no sense. Now I'm left with option 1 and option 4. One thing I noticed that's different is that option 1 has a rightward shift of 7, option 4 does not. My graph definitely looks like it's been shifted to the right 7 units, right? Because usually this max here for a cosine function lies on my y-axis. But in this case, it's not. It's been shifted to the right 7 units. And so I know that number 1 is going to be my answer. Another way you could have thought about this too is that another difference you see is that option A is positive 7.5 for our A value. Option 4 is negative. When I look at this, this looks like a normal cosine function that has not been reflected over its midline. And so I know that that A value needs to be positive, which again reinforces my choice of option 1.